Now, let us take this example. This is example 46 of your textbook, which says that a block of mass 200 gram is suspended through a vertical spring. The spring is stretched by 1 centimeter when the block is in equilibrium. This is the first statement. So, what is happening? There is a spring and this is a spring. Say this is the neutral length of the spring. This is the neutral length of the spring. But when it is attached to a mass, this is the neutral length of the spring. Now, I should not draw the mass here. This is the neutral length of the spring. This is the neutral length. But when the mass is connected to this, a mass of 100 gram, that means, say this mass is M1, its mass is 0.2 kg. A mass of 0.2 kg, and this extension of the spring due to this mass 200 kg, 200 gram is 1 centimeter. This extension is given as 1 centimeter. Now it's what it says. A particle of mass 120 gram is dropped on the block from a height of 45 centimeters. That means from a height of, say, 45 centimeters, let us say this condition, a small mass is dropped on this, and this mass is 120 gram, that means 0.12, that means 0.12 kg. And it also says this height is 45 centimeter, that means 0.45 meter. Right? Then it further says the particle sticks to the block. That means for whatever reason, this M1 and M2, let us say this is M2, they stick to each other. Then final question is, find the maximum extension of the spring. Now, what will happen actually? When this particle drops from a height of 0.45 meter and sticks to it, obviously, what will happen? Due to the kinetic energy of the body, the spring will extend further down. The spring will extend further down. And here, this small body is stuck to it. Find the maximum extension. That means they want us to find out the spring neutral was here. From here to here, what is the maximum extension? That is, they want us to find out. Earlier already it was 1 centimeter, and including that 1 centimeter, what is the maximum extension? Though it is not given in this problem, you should understand the spring thereafter will have a oscillatory motion. It will again go up and again go down, and finally it will come to steady state. But anyway, this is the maximum extension, because when it jumps upward and again comes down, it will not come down to this extent. It will be a little bit higher due to loss of energy, natural loss of energy. Anyway, this distance they want us to find out. Now we start this way. The spring is already extended by 0.1 centimeter. The spring already extended by 0.1, now 1 centimeter. It is, that means 0.01 meter, that by 0.01 meter by a force. What is the force? Force is mg. M is 0.2 kg into g is equal to 10 equal to, right? So by the spring formula, this force is spring formula, force F is equal to spring constant K into X. From there we get the force is equal to 2. Force is equal to 2 equal to K. X is 0.01, 0.01. So from there we get K is equal to 2 upon 0.01 is equal to 200. This is one information we shall need in this entire sum. The spring constant K is 200. Then the spring is already extended, so it is already containing a potential energy. The initial potential energy, the spring is already extended, and its initial potential energy. Initial potential energy, let us write, this is potential U initial is equal to half K x square is the formula, is equal to half K is 200 into X is 0.1 centimeter, that means 0.01 whole square. This is equal to 0.01. So initial potential energy of the spring before the impact is already 0.01 joule. This also we shall need later on to solve the problem. Now let us find at what velocity the small body, 120-gram body, strikes the big body. Say M2 strikes M1 velocity u. In that case, we know u is equal to under root 2gh. We know from the kinematics, where g is 10, h is 0.45 meter. That means 2 into g is 10, h is 0.45 whole under root. 0.45 into 10 is 4.5 into 2 is 9 under root. This is equal to 3 meter per second. This also we shall need later on. This is the velocity with which M2 strikes the bigger body. Then let us impose the law of conservation of momentum. Law of conservation of momentum. Let us impose law of conservation of momentum. Law of conservation of momentum. The smaller body which drops, the smaller body of mass 0.12, that multiplied by u is equal to. Now the problem says they stick together. So their joint mass is 0.2 plus 0.12, that multiplied by v. Now what is v? V is the downward velocity of the joint mass. That means if both of them together starts dropping with an initial velocity v, then law of conservation of momentum gives me this equation. From here we find 0.12 into u is 3 is equal to, this is 0.2 plus 1 to 0.32 and 32 into v. From here we get v is equal to 0.12 into 3 by 0.32. This is equal to 0.36 by 0.32. This is equal to 9 by 8 meter per second. This is v. That means the initial velocity with which the joint mass starts shooting down. Right? Now we shall make some more space here and continue. Now we have got the initial, we have got the mass, we have got the velocity v with which the joint body starts dropping down. Now, kinetic energy, then what is the kinetic energy of the joint mass immediately after impact? Kinetic velocity of the joint mass is 9 by 8 meter per second. Then what is the kinetic energy of this joint mass? So we write kinetic energy of the jointed mass immediately after the impact is equal to half mv square, is equal to half mv square. That means half, and joint mass is 0.32 and v is 9 by 8. So it is 9 by 8 whole square. If this you calculate, you will find this is 0.202025 joule. So this is another important information that we have received. Its immediate kinetic energy of this is now with this kinetic energy, the joint mass will start cooling down. That means now what will happen with this kinetic energy, this joint mass will start shooting down and it will come down to the lowest point when this kinetic energy is totally exhausted. Now what we do, we consider this additional extension. That means originally it was here, and this additional extension, we consider this additional extension is delta. So that the total extension of the spring from its neutral is delta plus 1 centimeter. Say the additional extension of the spring is equal to delta. So that total extension delta plus 0.01 meter. This will be our answer finally. But we have to find out delta first. We can easily find out delta first. Now mind it, the energy that we have in hand is 0.2025 joule. This is the energy that we have in hand. How this energy will be spent? When the spring comes down by another delta, then there is an increase in the potential energy of the spring. So that is one expenditure of this energy. So final potential energy of the spring, equal to half K is 200 and delta plus 0.01 whole square. This is the final potential energy spring. And also the initial potential energy of the spring that we have already calculated. Initial potential energy of the spring was 0.01 joule. 0.01. So what is the increase in potential energy of the spring? Taking these together, so in potential energy, the spring is equal to this will get cancelled, so it will be 100 into delta plus 0.01 whole square minus 0.01. This is the increase in potential energy of the spring. So this is one way the kinetic energy will be. This is the one way this kinetic energy will be spent. There is another way the kinetic energy will be spent. Mind it. When this joint body drops by delta towards the earth, then there is a loss of gravitational potential energy also. That also we need to consider. So we write also the loss of gravitational potential energy of the combined body is mgh is equal to 0.32 g is 10 and by delta is equal to 3.2 delta. If that is so, then the body had a kinetic energy of 2025. The body had a kinetic energy of 2025. So let us write this. Kinetic energy of the combined body, kinetic energy of the combined body equal to will be equal to gain in potential energy of the spring, gain of potential energy by the spring minus loss of potential energy of the combined body. And body. Now we have all the figures in front of us, so we just have to put them together. The gain in the kinetic energy of the body was 0.2025. So we find 0.2025 is equal to the gain in potential energy spring of the spring is 100 into delta plus 0.01, sorry, whole square, delta 0.01 whole square, minus, there is a minus 0.01 here already, right? So this is one part. The part is minus 3.2 delta, the loss of gravitational potential energy. 3.2 delta. From here we find this square part we take to the left-hand side, 100 into delta plus 0. Square minus 0.1 minus 3.2 delta minus 0.025 is equal to 0. From here we find, let us solve it vertically in one vertical line. That will be, from here what do we do? So from here we get 100. This is delta square plus 0.0001 plus this will be 0.02 delta minus this square is over minus 3.2 delta minus now minus 0.2025 and minus 0.025 0.01, this makes minus 0.0.2125. This is equal to 0. From here we find 100 delta square plus 0.01 plus 2 delta minus 3.2 delta minus 3.2 delta minus 0.2124. From there we find 100 delta square minus, now how many deltas we have? We have 2 delta here and minus 3.2 delta. So it is equal to minus 1.2 delta. Minus, now once again, we have 0.01 plus, and this is minus. So we have minus 0.205 equal to 0. From here we get, so delta is equal to, now we can go straight to quadratic equation solution, minus b, minus of minus 1.2 plus minus under root plus minus under root, b square is 1.2 whole square and 2 whole square minus 4, a is 100 and c is again minus, so it will become plus 0.2025 divided by 2 into 8. If you calculate this, you will find this is 1.2 plus minus under root 82.44 by 200. This is equal to 1.2 plus minus 9.08 divided by 200. Now, delta we know is positive. So it cannot be 1.2 minus 9.08. It can be only 1.2 plus 9.08 by 200. Right here, since delta is positive, this is equal to 0.05, sorry, this is equal to 0.0514, the value of delta. So the spring extends further. So the spring extends further by 5.14 centimeter, 5.14 centimeter due to the impact. Then what is the total extension of the spring? It was already extended by 1 centimeter. So the total extension of the spring is equal to 5.14 plus 1. 1 centimeter it was already extended, so it is 6.14 centimeter. This is the answer to this question. Right? Now we shall go to the next question now.